This video is on solving rational inequalities. A rational inequality is an inequality that contains at least one rational expression. In order to solve a rational inequality, we're going to follow the following steps. First of all, we want to identify the excluded value or values of the variable. In other words, what values of x make any denominators equal to 0. Then we're going to solve the related equation. We're going to ignore temporarily the fact that it's an inequality, has a less than or a greater than sign, and solve it as though it were an equation. Then we're going to use those excluded values and the solutions that we determined to divide a number line into intervals. And lastly, we want to test a value in each one of those intervals to determine which intervals contain values that satisfy the inequality. So, quite a few steps, sounds a little complicated, but let's take a look at a couple examples. First example we have here is x over 3 minus 1 over x minus 2 is less than x plus 1 over 4. So the first thing I want to do is identify any excluded values. My denominators are 3, x minus 2, and 4, so the only one that contains a variable is x minus 2, so that tells me that x cannot be equal to a positive 2, because when x is positive 2, this denominator is 0, so 2 is one of my excluded values. Now let's solve the related equation. So let's just imagine for a moment that this is an equal sign and we need to solve this for x. So this is a rational equation, so I'm going to multiply the entire equation by the common denominator, which would be 3 and a 4 and an x minus 2, and then distribute that to each one of these expressions. So distributing it to x over 3, the 3's will cancel out and I'm left with 4x times x minus 2, and then distributing it to the second, the x minus 2's cancel out and I'm left with a minus 12, and then distributing it to the last term, the 4's will cancel out and I'm left with 3 times x plus 1 times x minus 2. And so now I have just a straight equation that's a little simpler to solve here. So let's go ahead and distribute here. So 4x squared minus 8x minus 12 is equal to, when I multiply these two binomials, I get x squared minus x minus 2, and now let's distribute 3 to each one of those. 3x squared minus 3x minus 6. And I'm noticing that I have a quadratic equation because I have an x squared term. So I want to set this equal to 0. So let's move all of our terms to the left side of the equal sign. So subtracting 3x squared on each side is going to give me x squared. Adding 3x to both sides is going to give me a negative 5x. And adding 6 to both sides gives me a negative 6. And then I notice that that is factorable. X squared minus 5x minus 6 factors into x minus 6 times x plus 1. So that gives me values of x that are 6 and negative 1. Okay, so now I want to put those three numbers on a number line. So I'm going to use the two solutions that I got and my excluded value. So negative 1, 2, and 6. And it doesn't have to be exact, just make sure they're in the right order, because we're going to notice that these three numbers divide the number line into 4 separate intervals, numbers that are less than negative 1, between negative 1 and positive 2, between 2 and 6, and then greater than 6. So I'm going to choose a value of x in each one of those intervals, plug it into my original inequality, and see if it works. So for the first one, I'm going to choose x is equal to negative 2. So when I plug negative 2 into my original inequality, I get negative 2/3 minus 1 over negative 4. Is that less than? Negative 2 is going to give me a negative 1 over 4. So is negative 2/3 plus 1/4 less than negative 1/4? Is negative 5/12 less than, and I'm going to turn that into 12s, negative 3/12, and yes it is. So this interval would be a yes. So it does work on the interval x is less than -1. So let's try a value in here. So I'm going to choose x equals 0 because 0 is in there, and that makes it a little bit easier. So is 0 over 3 minus 1 over -2 less than 1/4? So that's a 0. Is 1/2, notice minus a -1/2, is that less than 1/4? It is not, so that interval does not work, so that would be a no. Actually, I'm going to write those. I don't know if I can erase that. I'm going to write it here so it stands out a little bit better. So that does not work. Now let's choose a value between 2 and 6. I'm going to choose x equals 3. And when I plug 3 into my original inequality, I have 3 over 3 minus 1 over 3 minus 2 is 1. Is that less than 4 over 4? Is 1 minus 1 less than 1? Whoops. So is 1 minus 1 less than 1? Yes, it is, because 0 is less than 1. So this interval works. And my last interval, x is greater than 6, I'm going to choose x equals 7. And plugging 7 into there, I get 7 over 3 minus 1 over 7 minus 2 is 5. Is that less than 7 plus 1 is 8 over 4? Is 32 over 15, I kind of went ahead there, is that less than 2? Actually, 32 over 16 would be equal to, or better to look at it, 30 over 15 would be equal to 2, so that does not work. So I'm noticing that this interval right here works, and this interval right here works. So my final answer is going to be x is less than -1, and I'm choosing a less than because it's not a less than or equal to. Or, and remember when I use the word or, it means I'm keeping both parts of it. 2 is less than x, which is less than 6. So any values that are in those regions are going to work in this inequality. Now that one was a little complicated. Lots of steps to that. We had 4 intervals, so we had 4 values we had to test. Let's take a look at another example. This one I think is maybe a little more straightforward. 4 over 3x plus 7 over x is less than 5/9. So taking a look at this, let's choose our find our excluded value. Since I have a 3x and an x, my excluded value is going to be 0. X cannot equal 0. Let's solve the related equation by multiplying by the common denominator, which would actually be 9x. And then when I distribute each time, each of the 3 times, the x's cancel. 9 over 3 is 3, so that leaves me with 4 times 3 plus 7 times, my x's cancel, 9 is less than 9's cancel 5x. As you can see, this one's going to be a lot easier. So 12 plus 63, oh, I'm sorry, I want to make that an equal sign. 5x, 75 equals 5x, so x is equal to 15. So now I only have 2 values that I need to test. Let's draw the number line. My excluded value of 0, my one solution that I found, 15, so that gives me 3 intervals. So let's test x equals -1. So plugging in -1 gives me -4/3. Move it this way a little bit. -4/3 minus 7, is that less than 5/9? Well, I don't even have to go any further because I know this is going to give me a negative number, and every negative number is less than 5/9, so that interval is going to be a yes. Let's pick something between 0 and 15. I'm going to pick x equals 1. So plugging in 1 is going to give me 4/3 plus 7. Is that less than 5/9? Well, no, it isn't, because that's going to be 8 1/3, and that's not less than 5/9, so that would be a no. And then choosing a value that's larger, I'll go with 16. That does kind of give me a big number, but that's okay. So plugging in 16 gives me 4/48 plus 7/16. Is that less than 5/9? Using my calculator, I ended up with, this was kind of a strange number. I decided to go to decimals for this one because I was having a hard time figuring out from the fractions. So is 0.52083 repeating less than 0.5 repeating? Yes, it is. That's going to be a smaller number, so this interval is a yes. So my intervals are going to be this here, kind of like drawing it on the number line, and this interval here. So then writing that, that's going to be x is less than -1, and again, this is also an or. X is greater than 15. So in this video, we took a look at how to solve a rational inequality different from solving a rational equation. So we need to identify the excluded values and the solutions to the related equation. Put those values on a number line so that it creates intervals, and then test a value in each interval to see which of those intervals contains solutions to the inequality.